It's not automatic. It's automatic over here. It's not so automatic here. It really doesn't kind of exist over here. Okay? So that's just something. Now, your company that you go to work for is going to say, we do modeling here, we do meshing here, and we do solving here, and you just say, that's fine. I know how to work with it. I know how to kind of deal with it. Defeaturing. Which of these two models is the right model to mesh? Is the one on the left the right one? The one on the right the right one? Or is there even a better model still? Okay. Kind of depends on the situation. If we have some pipes that are going through here, and the pipes actually have heat or something going through them or cooling going through them, and the pipes have a nice fillet edge around them that sits down inside there, and we want to transfer the temperature or something like that across into this, okay? That's a heat sink kind of design. Then maybe the one on the right is the right one to go with. Excuse me, the one on the right is the right one to go with because we want to keep these features. We don't care about this radius on the outside. But if it's just a structural thing that we're looking for, maybe we don't want either one of these models. We want to lose the radius that's actually there. How do we choose the correct element type and the correct element order? You know, do we go with a really dense mesh? Do we go with this kind of mesh? Well, here's a little analysis that I ran that we can look at really quick. So the top object took 4 seconds to come up with a solution. The element size was 0.3. It was first order. On the left, it took 220 seconds to compute. It's a 0.05 element size, and it's first order. This one on the right, 32 seconds. It's a 0.1 element size, and it's a first order. Then we did another set. It took 0.3 size element, second order, but it took 18 seconds. It took 1,086 seconds for the 0.05. It took 47 seconds for the 0.1. What I think you'll find interesting is on this table. What if I wanted to kind of optimize and get the best results? What should I have? Which option should I have chosen? Second order 0.3. So just going from a kind of a crude, fairly large mesh, okay, 14 seconds versus 18 seconds, but I go from this result, accuracy, okay, that's the load, okay, to this, and notice that they all lock in on about, what is that, 5,800 thousandths. So we don't have to just keep driving the size down. Notice that we're not even to the answer, assuming that 58 is the correct answer. We're not even to that answer going to a 0.05 element size on first order. So a little bit about material properties. In your CAD system, hopefully you know how to bring up the material properties. The thing that you may not have noticed is that most of the information is what? Most of the information that's in there is blank. Okay? The material property files that are furnished by the CAD vendors have the very basic Poisson's ratio. It has very basic material information. If you want to get better results and you're using a solver that can take into account the other properties, the other material properties, then it's really up to the company to go and fill these in. 8 years ago, 9 years ago, when I first started working with Honeywell and Pratt & Whitney, I went into those companies and was watching their engineers work on these things, and they would just kind of pick a material property and assign it to different things. And I would say, are you getting good results? I said, well, not as good as we kind of were hoping or expecting. And I said, well, when you do finite element out in ANSYS, what does your material card, what does your material property file look like? And they said, oh, well, it looks like this, you know, and it's completely filled in. In fact, it's mini cards. It's not just one, but it's mini cards all filled in. And I said, what does your material card look like over here in your CAD system? And so they printed out their finite element deck, and it was one partially filled in line. And I said, did you expect something different? It's written by a bunch of CS people put this data in there. If you want to make it so that it's good data, you need to make sure that you populate this with your company proprietary material information. And so when you go to work in industry, one of the things that you may want to just glance at is to see whether industry has really gone in there and filled in the information that the CS people don't appreciate, don't care for. Okay, here's a good place to stop. We'll pick up here